Right. So my lab focus on nature-inspired engineering. So what we do is we look at a biological system or like system in nature, take some of their concepts and create new materials or devices. And a lot of time we use these materials for different engineering applications. So that's kind of the overarching frame of my research.
So I'm currently working on the slippery rough surfaces that I showed you. They're surfaces that are sort of a hybrid between the lotus leaf inspired surfaces and pitcher plant inspired surfaces. So these are surfaces that are rough but have a conformal lubricant layer on it. And in particular, I'm focusing on how the roughness affects the contact angle of the droplet.
How did I find Dr. Wong's lab at Penn State? I was trying to find some sort of research involving materials at Penn State, and I was also trying to find some sort of research that involved the biomimicry, just I've been reading online about a lot of like cool attempts to copy what we see in nature, such as the abalone shell and all these like super materials derived from things in nature. And after just looking through the university's different departments, I ended up finding Dr. Wong. His research is aligned with my interests really well.
So with regards to how everybody works together in the lab, usually the undergraduates are assigned to a graduate student, and then we'll get a project from the graduate student, or we'll work on something that they're working on and hopefully gather data so that they can get results for their papers. And of course the graduate students also work underneath Dr. Wong, who's like the principal investigator, so he guides like the direction of the research lab. And then also the undergraduates have some interfacing, like interaction between us and Dr. Wong when we're trying to meet about mentorship or like what our goals are or what we'd be more interested in other projects we'd like to work on.
Our research is actually trying to introduce a self-healing property into the slippery rough surface and also different slippery surfaces. And what I do is to use the thermal stimulation to enhance the chemicals in mobility in the surface. That's why the surface configuration is a chemical compound that can self-heal itself.
So the research that we're doing in general is deals with slippery surfaces. And slippery surfaces are useful for a wide range of applications, from condensation heat transfer to water harvesting in dry regions to repelling liquid on airplane wings to prevent icing, which is of course dangerous. So there are a wide range of applications.
But when we talk about his research, I'm quite interested, as I did a lot of bio-inspired research when I was an undergrad back in China. I actually did some gecko-inspired patients back in the lab, so I'm quite interested in his research inspired by the pitcher plant. So that's why I joined his group immediately when he offered a position here.
So we work very closely together. So typically, myself, I work very closely with my graduate student. We talk about like research idea, and then we plan out for experiment together. And the graduate student mostly of course they're the person who really like work on the experiments and do the experimental measurements and create the surfaces. And we also recruit undergraduate student who work very closely with the graduate student and with different kind of experiments and so forth. And after they collect some experimental results, then we will meet from time to time just to see if there's any interesting things that we should explore further, or the results is we can find some interesting application for some of the results.